In this video, we'll be looking at how you use an ammeter to measure the current in a circuit. An ammeter has the circuit symbol of a circuit with the letter A in it, obviously for ammeter. And ammeter measures current. It must be wired in series or put into the path of the circuit. So what that means is if you have an electrical circuit, where you have some resistors and a battery, and let's say for example, then it's important to note that the current, let's call that current 1, let's call this current 2, let's call this current 3. The current everywhere in the circuit, because I've made a mixed circuit here, isn't necessarily going to be the same. If these resistors have different values, then all three of these currents will have different values. So to use an ammeter, I guess the first thing you need to know is where in the circuit do you want to measure the current. And then if you decide, once you've decided that, then you can put the ammeter in that location. Let's say, for example, that we want to know what current 2 is. Then what I can do is I can erase, the part of the circuit where I2 is, and we can insert our ammeter right there. You can see that you had to physically separate the circuit and then reconnect the circuit so that the current passes through the ammeter to connect the ammeter properly. So just a couple things about this. First of all, when we do these ammeters, there should be a red side and a black side. So the red wire should attach, on this side. That's the side where the battery is positive, and we usually use red to represent a positive battery. The negative side, or the black side then, should attach over here. This should be the negative end of the ammeter. Now, there's two basic kinds of ammeters you're going to run into. The more common, what you're going to find if you ever are working with this in the real world, is a multimeter. This is a meter that's designed to measure current, voltage, resistance, whatever it is you're trying to find. Has this dial in the middle, and the dial can sort of rotate to all these different settings, and then based on which setting you choose, you can measure current, voltage. What's important about this is that there'll be a black spot and probably a red spot on the bottom, and these red and black are typically used for measuring voltage. Well, the red is typically used for measuring voltage. The black is kind of a common that's used for voltage or current or whatever. There'll be a couple other spots. They might be labeled 1A or 5A, and the A here is a clue that those two spots are the ones that are used for measuring current. When you're hooking your ammeter into the circuit, it's critical that you have your multimeter set so that you're using the input spots that are corresponding with current, so that you're not trying to measure a voltage, you're measuring a current instead. If you try to use it to measure a voltage, just nothing will happen. Now, what the other type is is sort of the old style, and they kind of look like a box like this. And there's inputs here. Typically there'll be 3, and there'll be a 1 amp and a 5 amp. And then there's sort of a reading scale across here, and one of the reading scales will end with a 1A and the other reading scale will end with a 5A. Depending on which of these circles you're connected into should tell you which of the scales you're trying to read across the top. And then there's a little arm. If you hook up the old style ammeter backwards, what will happen is this arm will try and move in the wrong direction. This is no big deal. Just take it out, switch the red and the black, and then put it back in, and it'll work fine. If you are trying to hook up a multimeter and you hook it up backwards, then the reading on the scale will just read something negative. And that's fine. You can just ignore the negative and move on, or you can switch the connections if you want to. It's up to you. How does it actually work? Ammeters rely on Ampere's law. Ampere's law says that when a current passes through a wire, it creates a magnetic field, and we can measure the strength of that magnetic field with a magnet. So imagine, again, here's that same circuit from above, where this is where we're going to put our ammeter. So as discussed above, this is sort of where the ammeter is going to go. But what is an ammeter really? Well, really what it is it's a very small resistor. That very small resistor will add resistance to the circuit. It adds resistance, and that is a source of error. However, that's how it's done. That small resistance, that new path has some sort of current flowing through it. As it's become part of the circuit, the current that was going to flow through that branch now has to flow through that circuit, and that's going to create a magnetic field, and that magnetic field is measurable with a magnet. This resistance is often small enough that it's essentially ignorable, but it's there and it can affect your results. For measuring voltage, we use a voltmeter. Symbol is a V in a circle. And it's a little bit easier to hook up a voltmeter than it is an ammeter because you don't actually have to break up the circuit. If we again imagine our same circuit, and we want to measure the voltage across that last resistor, again this guy, then all we have to do is wire a voltmeter in parallel around the side of it. Recall that voltage is the amount of energy that an electron gets from moving from one part of a circuit to another part of a circuit, and is a result of the different number of electrons in those two different parts of the circuit. So we can almost think about the voltmeter as touching the circuit at A and B and measuring the number of electrons at A and the number of electrons at B, and comparing those two things. And you can see why it doesn't need to be part of a circuit. How does it actually work? Oh, I guess just to remind you, going back up to the multimeter, there's just if you have a multimeter, you just have to make sure that you're using the red and common connection if you're measuring voltage. So if you've switched it over to measure current, you got to remember to switch it back. If you use one of those old style voltmeters, you really can't mess those up. They're sort of foolproof. They just have a black connection and a red connection and an arm, and usually there's just one connection each for a volt for one of these old style voltmeters, and if you hook it up the wrong way, the arm will try and go the wrong way, and then you just have to switch the wires as we discussed earlier. How does it actually work? Well, again, if I imagine this is the resistor that I'm trying to measure the resistance of as part of the whole circuit. Oof. Drawing's getting worse. There's a resistor, battery, and back. Okay. If you wire this thing in parallel, here's your voltmeter like this. What is it really? Well, what it really is it's a very large resistor. Okay? That very large resistor means a tiny current will flow down that part of the circuit. This tiny current is a source of error. It shouldn't be there in the normal function of the circuit. But again, it's tiny, so hopefully it's not affecting results too much. This tiny current creates a magnetic field. The magnetic field can be measured in the same way as the magnetic field that was created in an ammeter. So that's how you use the voltmeter and ammeter. So that.